All right, what's up, Math 8? So today we are going to do lesson 2.5, which is solving multi-step equations. All right, it can be a little bit, at first, just a little bit overwhelming, but just keep in mind, it's really just the same thing that you've been doing with one-step and two-step equations. It's just you're adding an extra step. There's nothing in here that you haven't seen before in a smaller capacity. So don't get too scared of it. And yeah, we'll just work through it. All right. So we'll start here with example number 1. So this is a good example of we've got grouping symbols, so parentheses. And so the best way to do something where we have parentheses like this, and we're looking at an equation like this, is to use distributive property. All right, so I'll go ahead and put this here for you. Make sure you get this written into your notes. All right, so there you go. Use the distributive property when you have parentheses. Okay, so we'll go ahead and look at the example. Okay, so for this example, we've got 15 times the quantity 20 plus d equals 420. All right, so the first thing that we're going to do is we're going to do the distributive property. All right, so we're going to distribute that 15 onto both things in the parentheses. Now remember, you multiply, right? So you multiply here, you multiply here. Okay, so the first one, 15 times 20, is going to give us 300. Okay, and then the second part, if we do 15 times d, that's going to give us positive 15d. Okay, so there's that side. And now we just have a two-step equation, just like we've been working with in the past. All right, so now we just go ahead and solve like normal. So do the addition and subtraction first. All right, and there we go. So that'll cancel. And then we're left with 15d equals 120. All right, and then finally, to isolate the variable, we will divide both sides by 15. We will be left with d equals 8. Okay, and that is your solution for example number 1. So make sure you get that down. Make sure you understand the steps. Once you've done that, I want you to try out, go ahead and try out, let's do B. So go ahead and try out B on your own once you have finished that example. All right, so now we've got a little bit of vocabulary here. Okay, so we've got 3 types of solutions. All right, there's solutions where we have no solution. There's solutions where we have just one solution. That's what you're typically going to see. All right, that's all the ones that we've done already. They've all been one solution. All right, and then you can also get infinitely many solutions. Okay, so I'm going to show you an example of each one. All right, so if we have 3x plus 4 equals 3x, okay, this is the same example they're showing you over in the box. So if you just want to look at that, that's okay too. But make sure you understand how it works. Okay, so if we were to solve this, what we would do is, remember, we want to get variables only on one side. Okay, so we're going to subtract 3x over here so that this will cancel on this side. Okay, which means we've also got to subtract 3x on this side. Okay, now when we do that, we're going to be left with 0x, which means it also cancels. So now we are left with 4 equals 0. Okay, 4 equals 0 is not true, right? There is never ever going to be a time where 4 and 0 are equal to each other. All right, so since they are not equal, this means we have no solution. All right, it's also up here, they call it a null set, but I am totally fine with you just saying no solution. All right, so there's the first example. The next example is if we have one solution. All right, this is like most of the problems that we've done in the past. So again, just to show an example, we have 2x equals 20. If we divide both sides by 2 in order to isolate that x, the 2's will cancel. We're left with x equals 10. Okay, that is the only solution to this problem, is x equals 10. Okay, and then lastly, our final example is an identity. All right, so an example of that, an identity has an infinite number of solutions. All right, so an example would be if we have 4x plus 2 equals 4x plus 2. All right, what we're going to want to do to solve this, go ahead and subtract 4x from both sides because we want to get the variables only on one side. So it cancels here, but then when we go over to the other side, we realize it also cancels here. All right, so we're left with 2 equals 2. This is always true. All right, so up here with this one, we had that 4 and 0. 4 being equal to 0 is never true, but 2 being equal to 2 is always true. All right, so this is going to be infinitely many solutions, or you can also write all real numbers. And then the symbol, if you're interested, instead of having to write all real numbers, you can write an R with a little line through it right here. Okay, that is also the same thing as all real numbers. All right, so that is an example of an identity which has an infinite number of solutions. Just to show you as well why that is, if we were to do it the other way, so subtract 2 from both sides, those would cancel, and we're left with 4x equals 4x. Any number that you plug in for both x's is going to make this true. So I could plug in 1, we're going to have 4 equals 4, okay? If I were to plug in 10 for both of them, that would get us 40 equals 40. If I were to plug in -2, just to show you an example of a negative, that would give us -8 equals -8, right? So the reason it's infinitely many is because anything you plug in for x there and x there, it's going to be equal on both sides. All right, so we're going to look at an example of this with multi-step equations. All right, so we'll look at example 2, which is at the top of your screen right now. Okay, so we have 6 times x minus 3 plus 10 equals 2 times 3x minus 4. All right, so our first step, as I said earlier when we were doing a similar problem, is that we are going to want to do the distributive properties. You're going to distribute the 6 onto the x and the -3. Okay, remember that minus sign goes with the number that's behind it. And then over here, we're going to do 2 times 3x and then 2 times -4. All right, so that's our first step. Remember, on this part, we got to do order of operations, which is why we do that multiplication in parentheses before we add the 10 right here. Okay, so just keep that in mind. All right, so we're going to start with the 6 times the x, which gives us 6x, and then we will do the 6 times -3, which is -18, and then we copy down the rest of that side. I like to go ahead and do the other side in the same step. So now we've got 6x when we multiply those two, and then -8 when we multiply 2 and -4. All right. Okay, so next we can go ahead and we can combine like terms. You'll notice on this side there are 2 constants, which means we can combine them. All right, so we're going to have 6x, and then we have -18 plus 10. that is the same as -8. All right, so we have 6x minus 8 is equal to 6x minus 8. All right, the next step that I'm going to do, I'm going to go ahead and add 8 to both sides to get this to cancel right here. And then I notice it also cancels on this side, so I'm left with 6x equals 6x. All right, anytime you have the same thing on both sides, all right, I'm going to write this down for you so you can remember to write it down. So anytime you have the same thing on both sides, that is all real numbers or identity. All right, these are the same thing. Okay, keep in mind this is all the same thing, including that. So anytime you've got the same thing on both sides, you've got an identity, which is all real numbers. And right here, we see we have 6x equals 6x. So this is an identity. The answer is going to be all real numbers. Okay. All right, so now we're going to move on to example 3. All right, which is going to be, whoops. It is 8 times the quantity of 4 minus 2x equals 4 times the quantity 3 minus 5x plus 4x. All right, so we'll go ahead and solve this one. I'll solve it for you again. So we have, again, the distributive property here and here. Again, that's multiplying. And we also will have it on this side. We're going to multiply there. We're going to multiply there. All right, so 8 times 4 is 32. And then 8 times negative 2x is negative 16x. All right, and that is equal to 4 times 3, which is 12. And we have 4 times negative 5x, which is negative 20x. And then we have the 4x added on to the end. All right. Our next step is going to be on the right side. You can see we've got a couple of like terms that we can take care of. So I'm just going to rewrite all of this over here. And then on the right side, we have 12 minus negative 20x plus 4x, which is going to give us negative 16x there. All right, my next step is going to be, I'm going to want to get rid of the variable terms being on both sides. So I'm going to add 16x to this side so that I can get rid of it on that side, and we're just left with a constant, which means I've got to do the same thing to both sides. So we'll cancel there. I'm going to notice it also cancels right there. All right, so now I am left with 32 equals 12. Okay. Once again, we should notice here, 32 is never ever equal to 12, which means we have no solution for this one, okay? So nothing we put in for x will ever make this problem true. All right, so once you've got that copied down and you understand it, I want you to pause the video. I want you to try, let's do problem C, okay? So give that one a try. Once again, pause the video, and then we will move on once you get problem C done. All right, we're going to look at one final example. Okay, this one is a word problem. Okay, so we have at the fair, Hunter bought 3 snacks and 10 ride tickets. Each ride ticket costs $1.50 less than a snack. If he spent a total of $24, what was the cost of each snack? So our first step would be to write out the equation to represent the problem. So he bought 3 snacks. All right, there's our 3 snacks. All right, and then he bought 10 ride tickets. Okay, so the ride tickets, we've got 10 of them there. They cost $1.50 less than a snack. So that's going to be S minus 1.5. All right. If he spent $24, how much is a snack? That total there is 24. So we know that goes on the other side of the equal sign. All right, and now we just solve. Okay. So we have 3s plus 10 times s is 10s when we do the distribution. We got to distribute the other one as well. So 10 times negative 1.5 is negative 15. And that all equals 24. All right, now I'm going to combine like terms. So I've got 13s minus 15 equals 24. All right, add 15 to both sides. We've got 13s equals 39. And finally, divide everything by 13 to isolate the variable, and s equals 3. All right, so each snack costs $3. All right, and that is it for that example. So once you've got all that copied down, you understand it, go ahead and just prepare to return to class, and we're going to talk about this. I know it was a lot, so we will take our time to talk about this. I will see you guys in class.